When we left off, we were on page 97. On page 97, we worked the first few problems together. Again, we're dealing with inequalities. And up till now, through the lesson you just did, they followed the same pattern as two-step equations when you were solving for them. The only difference, again, or the main difference, inequalities and equation, inequalities have infinite number of solutions, or at least they often have an infinite number of solutions, where equations tend to have a finite number, typically just one. And again, expressions have no sign. So you're not solving expressions. All you can do on an expression is simplify. You solve equations and you solve inequalities. Inequalities often have an infinite number of solutions. So as we take a look at page 97, we did the first few together. We were adding a constant to both sides or subtracting a constant from both sides. And the inequality sign remained unchanged. And that question 2, when you add or subtract the same number to both sides of an inequality, the inequality sign stays the same. The lesson we're going to be going into today is there's a certain circumstance when you multiply or divide both sides by a negative where it's going to flip, change directions, because negative also means opposite in mathematics. But let's take a look at pages 98 through 104 to make sure that you're on the right track and have the right answers. I'm going to scroll through them fairly quickly, but if you need to stop and look, just hit pause on the recorder or on the player, and you can look over your answers. Page 98, number 3. Both of these statements are true, that you can add or subtract an a to both sides because of the properties, the addition property of inequality and the subtraction property of inequality. Now take the information discussed and the pattern shown, and again, you solve the problems on 99 through 104. Page 99. For A and for B, for A it simplifies to x greater than 6, and for B I list the steps where you combine like terms and then you use the addition property of inequality. On 5, x greater than 6, the solution set includes all numbers greater than 6, but any number equal to 6 or smaller is not a solution. Still on page 99. 6A, Jim is 24 years old, and that Mike was 29. 6B, if Mike is greater than or equal to 25, then Jim is greater than or equal to 20 years old. He's at least 20 years old. 6C, if Mike is less than 30, then Jim must be younger than 25 years old. And I've done the graphs with the appropriate filled-in circle if it can be equal to, or the hollow circle if it can only be greater than or less than. Page 100 simplifies, 7A simplifies to x greater than 2, and I graphed it. Since x is greater than 2, then they asked us to test it with a different number. I just chose 10. And 10 should be part of the solution set, and it is. 7B simplifies to x greater than or equal to 35, and again, I just chose 40 to test it, and it does work out. 7C simplifies to x less than 14. I chose a number less than 14. I chose 10, and showed that it is part of the solution set. Page 100, 7D, x is less than or equal to 18. To test it, I chose a number less than or equal to 18. I chose 10 and showed that it was true. Number 8 just asks us to make up our own. I just used my sister. And so Susan is 3 years older than her brother Mike. That would be me. How old will Mike be if Susan is at the most 21 years old? Then my age is 3 years less than that. That was the x minus 3 less than or equal to 21. Again, answers on 8 are going to vary. You could have chose a different inequality to use. Page 101, 1A. Again, these are multiplying or dividing positive numbers, and the inequality sign is not going to change. It's going to remain unchanged if you multiply or divide both sides by a positive. And so 1/2 is less than 3, 6 is less than 12. Take a look at the distance, though, because the distance when you multiply or divide between the two numbers does change. It starts off, the distance between 3 and 6 is 3 units. Note, if you multiply by 1/2, the distance is 1/2 of 3. The distance between these 2 points is 1.5. If you multiply by 2, the distance between them doubles. And why? Well, 2 is the same. Multiplying by 2 is doubling. So just notice the pattern is forming, that if you multiply both sides by 3, the distance is going to triple. If you divide by 10, the distance became 1/10 of what it was. Page 101, 1C. Again, multiply by 3. And 9 and 18. 9 is still less than 18. The inequality sign doesn't change. On 1D, divide by 1/2. 3 divided by 1/2 is 6. Skip, flip, multiply. Mrs. Magana does an amazing job of teaching that. The 7th graders come to me knowing this because of her skills. So when you see Mrs. Magana, thank her because she does a great job of teaching. And again, notice all the signs stayed the same. Page 102, 1E, divide by 2. And so I showed it as an improper fraction, and then I showed it as a mixed number or whole number. Divide by 3. And again, nothing has changed. The sign is not changing. When you multiply or divide both sides of an inequality by the same positive number, then the inequality symbol remains unchanged. Note, since they didn't include negative numbers, there's probably a reason. And there really is going to be a reason, because when you multiply or divide by a negative, that inequality sign is going to become its opposite, because negative means opposite in mathematics, and it's going to flip directions. Page 102, number 3. Robin must have only multiplied or divided both sides of the inequality by the same positive value. Her constraints are restrictions, where that she only let her variable a equal positive numbers. For a, when you simplify, you get x less than 6, and I showed my steps. I simplified using multiplication, and then I used division property of inequality. On number 5, it simplifies to x less than 3. I use the division property of inequality. Number 6, again, the setup of it, they give us Michelle and Beth. Michelle is whatever Beth's age is times 3, 3 times Beth's age. So m equals 3b, or divide both sides by 3, b equals m divided by 3. Beth is 1/3 of Michelle's age, or Michelle is 3 times Beth's age. You're going to use one of these two equations each time when you're solving. If they give you Beth's age, use it to find Michelle. If they give you Michelle's age, divide it by 3 and you'll have Beth. So 6a, they give us Michelle's age and ask us to find Beth. Michelle is 27, or greater than or equal to 27 years old. So 27 divided by 3, Beth must be at least 9 years old. On 6, I simplify, Beth is less than 10. 6c, I simplify, Beth is 14 years old. And so equals 14 is just, there's no inequality there. It's an equation, so it has a solution. Page 104, 10x greater than or equal to 45, divide both sides by 10. X is greater than or equal to 4.5, and I've done the graph, and I've paid attention to whether to fill in the circle if it can be equal to, or leave the circle hollow if it's just greater than or less than, but it can't equal that number. Page 104, 7b. The solution, x is less than or equal to 63, and I've graphed it. Problem 7c, x is greater than 24, or you could say 24 is less than x. They mean the same thing. And I've graphed that. 8, I was asked just to come up with a problem that utilized one of these inequalities. I just made up, if you know that Bill's age is 1/3 of Mary's, and that Mary is at the most 21 years old, then what do you know about Bill's age? And so Bill's age divided by 3 is less than or equal to 21. Okay, page 105. As we go into 105 to 114, really the only thing I need to make sure you feel confident with is if you ever have to multiply or divide both sides of an inequality by a negative number, that the inequality sign is going to change direction. It's going to flip. Less than becomes greater than will flip to become less than. I put note, in math, a negative sign also means opposite. When you multiply or divide both sides of an inequality by the same negative number, the inequality sign flips or changes directions. And I give an example. We all agree that 1 is less than 5, and we graphed it on a number line. But if I multiply both sides by a -1, -1 times +1, well, that's -1. And +5 times -1 is -5. Well, in this case, -1 on a number line is bigger than -5. Remember, when you're dealing with negatives, the larger the negative, the smaller the number. So it's better to owe somebody $1 than it is to owe somebody $7 or $100. So -1 is bigger than -5. Note the opposite of less than is greater than. And I always remember less than looks like a bent capital L. If I wrote it less than so when I just see the symbol, that bent capital L comes to mind, so I can quickly look at it and go, oh, that's less than, that's greater than, even when there's no numbers associated. That what I just covered on that page, look over it if you need, but that's really what you need to get through pages 105 to 114. That's the missing piece for inequalities. Let's take a look at the first few on page 105. They give us, again, 3 is less than 6. That hopefully is extremely obvious. If I put them on a number line, 3 and 6, again, this is the larger side of the number line, the bigger or the larger, and this is the smaller. If I multiply both sides by -1/2, positive times a negative is a negative, 3 times a half is 1.5. 6 times a half, 6 times -half. Positive times negative is negative. 6 times a half, or half of 6, is 3. If I graph those on the number line, again, -3 is smaller than -1. So that our inequality sign changed direction. On 1b, we're multiplying both sides by a -2. 3 times -2, -6. 6 times negative 2, negative 12. Negative 12 is smaller than negative 6, so our inequality sign flips. We multiplied by negative 2, the opposite of 2, and our sign is turned. It becomes the opposite. Less than turned and became a greater than. Same thing's going to happen on 1C. We're multiplying both sides by a negative 3. The sign is going to change direction. This less than sign is going to turn into a greater than sign. 3 times negative 3, negative 9. 6 times negative 3, negative 18. I graph them on a number line. Negative 18 is smaller than negative 9. Use this information and see if you can solve the problems from 105 to 114. I'll provide the answers to those problems on the next video. And when you finish those pages, please go to Edulastic and take the assessment, Edulastic M3 105 to 114. Thanks. Good luck. Let me know if you have any questions.